Hello grade 10s and welcome to another physical science lecture in chemistry. Right now we're going to be dealing with the end of chapter exercises under quantitative aspects of chemical change. Here we go. Some important information. Okay, my mistake. So the important information that you should already be familiar with are the formulae, right? Number of moles is equal to mass in grams over molar mass in grams per mole. A number of moles is volume of the gas in dm cubed over molar gas volume, which is in dm cubed per mole. Or number of moles is equal to n, which stands for the number of particles in the sample, over Na, which stands for Avogadro's number, which is 6,02 times 10 to the power 23 particles per mole. Please take this down. I modified it from siavoda.com. So number 1 states, a sample of sodium hydroxide is dissolved in 2,4 dm cubed of water to form a solution with a concentration of 3 mole per dm cubed. 1.1 states, calculate the number of moles of sodium hydroxide used to form this solution. So write down the data that you have. So V is 2,4 dm cubed. Concentration 3 mole per dm cubed. So the units are correct. So the formula is C is equal to N over V, right? What is C? 3 mole per dm cubed is equal to, oh sorry, you don't, what is n? Okay, n is unknown, v is 2,4. So n is 3 times 2,4, 7,2 mole. One point two states, determine the mass of sodium hydroxide present in this sample. Remember, we're going to use this formula. Number of mole is equal to mass over molar mass. So sodium hydroxide is, this is the formula, because it's the sodium ion and the hydroxide ion, right? So the molar mass of sodium hydroxide is the molar mass of sodium, which is 23, plus the molar mass of oxygen, which is 16, plus the molar mass of hydrogen, which is 1. So the molar mass of sodium hydroxide is 40 grams per mole. So molar mass is 40 grams per mole. Number of moles is 7,2. So it's going to be molar mass is 40. Multiply both sides by 40. 40 times 7.2 is 288 grams. I hope that makes sense. 1.3 states, find the number of sodium ions present in this sample. So all the elements are in the ratio of 1:1:1, right? So we're going to say number of moles n over Avogadro's number, right? Number of moles is 7.2, 6.02 times 10 to the 23. So the number of sodium ions (4.33 times 10 to the power 24) ions. Okay, I hope that makes sense. Number 2 states, calculate the number of moles in 7,52 grams of methane. So the mass is 7,52 grams, right? You need to calculate the molar mass of methane, the molar mass of carbon, which is 12, plus 4 times the molar mass of hydrogen, which is 1, 16 grams per mole. Right? Then formula, number of moles is mass over molar mass. What is the mass? 7,52. Molar mass is 16 grams per mole. Number of moles is 0.47 mole. Okay, I hope that makes sense. Number 2, we have 25 grams of neon. Neon is a noble gas. Molar mass of neon is, when you use the standard periodic table, 20 grams per mole. So number of moles is mass over molar mass, 25 grams over 20 grams per mole. 1.25 grams per mole. Okay, I hope that makes sense. Roman numeral number 3, 0.5225 kilograms of titanium 4 chloride. Titanium 4 chloride is TiCl4, right? So what is the mass? It's 0.5225 times 10 to the power 3. So it's 522.5. Molar mass of titanium 4 chloride is molar mass of titanium, which is 48, plus 4 times molar mass of chlorine, 35.5. 190. Mass over molar mass. (522.5) over 190. (2.75) moles. I hope that is clear enough. Okay, Roman numeral number 4, 845.3 grams of potassium permanganate. There we are. So we need to find the molar mass of potassium permanganate. Molar mass of potassium is 39. Molar mass of manganese is 55. Molar mass of oxygen is 16. So it's 158 grams per mole. Mass is 845.3. Molar mass is 158 grams per mole. (5.35) mole. I hope this is clear enough, right? And I hope you understand. Okay. Number 3 states, calculate the mass of 3.1, 0.75 mole of magnesium hydroxide. So magnesium hydroxide, the formula, magnesium is Mg OH twice. Okay. So molar mass of molar mass of magnesium so molar mass of magnesium is 24. Molar mass of oxygen is 16. Molar mass of hydrogen is 1. So it's 58 grams per mole. Okay, I hope that makes sense. Remember the formula. Number of moles is 0.75. 58. Mass is 0.75 times 58. 53.5 grams. 43 rather. Yes, sorry. 43.5 grams. I hope that makes sense and that's clear enough. 3.2, 15.44 moles of krypton. So, krypton is a noble gas. Molar mass of krypton is, on the standard periodic table, it's 84 gram per mole. Mass is 1296.96 gram. That, I hope that makes sense. 3.3, 45.15 times 10 to the power of 23 molecules of nitrogen monoxide. Number of moles is N, which is the number of particles over Na, which is Avogadro's number. N is 45.15 times 10 to the power 23 over 6.02 times 10 to the power 23. So it's 7.5 mole. Nitrogen monoxide is NO, right? So the molar mass of NO is 14 plus 16, which is 30 grams per mole. And don't forget, mass over molar mass, 7.5. Mass over molar mass, 30. Mass is 7.5 times 30, which is 225. Remember, you don't write here, but it's just that I ran out of space. Okay, I hope that makes sense. Remember, the formulae are important. Please don't omit them. Okay, if you found this helpful in any way, please click the like button and subscribe for more content. I hope to see you again, and thank you very much.